Hey everybody, so Monday, August 31st is when you're going to be watching this video, so I'm going to try and make it short and sweet for us because I know that Group A is going to be here in the classroom and then Group B is going to be at home. So Group B, if you're watching this, if you have any questions, please send me a Canvas message or email me and I'll try and get to you as quickly as I can today outside of class. And obviously we'll have you in class tomorrow too so we can answer some questions. Group A, you'll see here I went ahead and wrote in the definition, so you do not have to, write those down if you do not want to, but you will have to know how to do the examples. So let's jump right in. Last week we talked about radicals. This week we're going to talk about triangle inequality theorems. So a bunch of triangle theorems. As you can see here at the top, I have drawn a couple triangles for you. I have A, B, and C, where A and B are both the legs. C is the hypotenuse. Okay, so that's a right triangle. You guys are very familiar with that. So the first theorem that we are going to recognize is called the triangle inequality theorem. The triangle inequality theorem states that the sum of any two sides of a triangle must be bigger than the third side. So basically, if I give you three numbers and say, can it be a triangle, like I did down here, okay, it can only be a triangle, it can only work if you use, if two of the three sides, like it is here, are bigger than the third. So let's go through example 1, 7, 11, and 3. So let's make sure, because you have to check it all three times, that it does work. So does 7 plus 11 equal out to be bigger than 3? Well, 18 is bigger than 3, so yes, there's 1. Okay, well, how about 7 and 3 bigger than 11? Okay, well, that's 10, 11. It is not, so therefore this cannot be a triangle. Okay, so when you're checking to see if three side lengths can be a triangle, you need to check all three just to make sure. Okay, all right. Number 2, do the same thing. So 8 plus 11, is it bigger than 7? Sure is. How about 8 plus 7? Yep, that's bigger than 11. So that's good. And lastly, 11 and 7 is the one we didn't do yet. And that's bigger than 8. So all three work. So yes, it is a triangle. And I apologize for the bad handwriting here. Okay, so that's how you check to see if three side measures can represent a triangle. Okay, so then another thing that you went through, I believe, last year was Pythagorean theorem. So when you do have a triangle, there's a way to tell if it is a right triangle. And that way to tell without knowing if it's got a 90-degree angle is you look at the sides. And it says here, the sum of the squares of two sides is equal to the square of the hypotenuse. So what that means is if A and B are the sides, their sum of those squares, so you're squaring both sides, should be equal to the square of the hypotenuse. Okay? So let's go through the example, find the missing side. So again, since this is supposedly a right triangle by this little mark here in the corner, that means this is our hypotenuse because it's always opposite of the right angle. So this is going to be B or A. It doesn't matter. A and B are interchangeable. And this is going to be our C. And we're going to set it up. So 5 squared plus 13 squared equals x squared. Okay? So again, we're looking for this side. Well, that's 25. This is 169. This is x squared. Okay, 25 and 169 gives you, let's see, 189, 194. Okay. Equals x squared. And at this point, now we can see we have 194, but here's the problem. 169 is a perfect square. 196 is a perfect square. So this is not going to be a perfect square. So this side length is going to be a little bit weird, right? So let's just use our calculator here. And let's see. Oops. That's not what I wanted to do. Okay, we'll do that. That's fine. That works. Or we'll get some adds. That's even better. So 194, we'll take the square root, is 13.9 and some change. Okay, so 13.9 and some change is about that side length. Okay. All right, number 2. Okay, right angle's right here. Where does it point? It points to the 6, so that's our C. This is our A, this is our B. So again, it should be equal. And so that, knowing the Pythagorean theorem is helping us to find the side length. So x squared plus 5 squared, because it's a squared plus b squared, equals c squared. Okay, so we're just solving the problem here. 5 times 5 is 25. 6 times 6 is 36. Okay, we're going to subtract 25. Subtract 25. X squared is 11. So take the square roots. Well, there is no perfect square that goes into 11. So the correct answer here would be the square root of 11 kilometers. And again, this would be a decimal, but we can just leave it as a simplified radical. Okay. All right, a little more complicated here. These ones say find the area, so we're looking for the area. We're not just looking for a missing side length. Keep your answers in simplest radical form when possible. So, in order to find the area of each triangle, remember that the area of a triangle is 1/2 base times height, or some of you know it to be base times height divided by 2. Same exact formula, that's okay. So what you need to know in that is your base and your height. And in a triangle, the base of any triangle is this, and then this is your height. So we need to know those two distances. Well, we almost do, except for this 10 only goes to here. Okay, that's representative of that. But we do know that the height is 4, so we can already kind of plug in here. So we have the base, we're still trying to find, the height is 4, and divided by 2. So we just need to find what is this little space. Well, if this is a right angle and this is supposedly a straight line, then that means that this is 90 degrees, and so is this, right? So if that's 90 degrees, well, now we have another right triangle. So we have, this is our hypotenuse, so this is our C, this is our B, this is our A that's missing. Okay, and so since it's missing, we're going to use the Pythagorean formula. So a squared plus b squared, which is 4, so 4 squared, equals c squared. Okay, and from here it's just solving an algebraic problem. 4 times 4 is 16, 5 times 5 is 25, subtract 9, so a squared equals 16, or I'm sorry, I'm so dumb, I'm getting ahead of myself. 16, subtracting 16 from both sides gives me 9. Okay, and then when I take the square root of both sides, because that's the opposite of the square, that means that a is the square root of 9, which is 3. Okay, now, that's not the end. That's just our base, right? That's what this part is. Okay, that's just that little piece. In fact, let me switch colors here. That's that little piece. So what is this entire thing combined? That's our base, and that was 10 plus 3, and that's 13. So our area of this triangle is going to be 13 times 4 divided by 2, or 4 divided by 2 is just 2, so 13 times 2 is 26, and it doesn't give us a unit, so we're just going to say units squared. So that's the area of that one. Okay, and that's our answer right there. Okay, on to number 4. Number 4, you can see this is another triangle. We have this line. It's called a perpendicular bisector. It goes right down through the middle. And we know that because these two sides are congruent, which means these two sides are congruent. So this is also 4.6. So again, area of a triangle, base times height divided by 2. So we know that our base here is 4.6 and 4.6, which is 9.2 when you add them together. We need our height, and we're going to divide it by 2. Okay, so our height is going to be, since this is the hypotenuse, it's across from the right angle, 4.6 squared plus b squared, or I guess we could use h for height here to be more appropriate, equals 6 squared. 4.6 squared is 21.16. And then you have your h squared and 36. Okay. Subtract 21.16. Subtract 21.16. H squared equals, let's see. Come on. Here we go. 36 minus 21.16 14.84. Okay, let's take the square root of that. Let's see. Right there. So our height is about 3.85. So 9.2 times 3.85 divided by 2. Okay, so clear. 9.2 times 3.85 divided by 2. So our area is 17.71. And again, I don't think it gives. It does not. So there's our answer for that one. Okay? All right, moving on. How to classify triangles. So not only do we have right triangles, but we also have obtuse and acute triangles. So the biggest way to figure them out is just by doing the formulas that you see here. So we can do Pythagorean theorem, a squared plus b squared equals c squared. And we can do the converse of that, which says a squared plus b squared is less than c squared. So if the number on the right or the hypotenuse squared is bigger than the side squared, it's obtuse. So if the hypotenuse is bigger, obtuse. Hypotenuse is smaller, acute. Okay, so let's check it out here. We have 3 side lengths, and it says state if the 3 side lengths form an acute, obtuse, or right triangle. Well, 6 squared plus 6 squared is, I'm going to put a box there because I don't know if it's equal, less to, or greater than. So 6 and 6 is 36 plus 36. 10 times 10 is 100. 36 plus 36 is 72. So 100, it is less than. So if it's less than, the hypotenuse is bigger, that is obtuse. Okay. Number 6. So we have 8 squared plus 12 squared equals 13 squared, maybe. Again, we have this like question mark. Okay, so 8 squared is 64. 12 squared is 144. 13 squared is 169. This number is clearly going to be bigger, and so therefore the hypotenuse is smaller, and it is acute. Okay, it's an acute little triangle. Okay, same thing here. 9 squared plus 12 squared is blank to 15 squared. So this is 81 plus 144. This is 225. 81 plus 144 is 225. So this one's equal, and therefore it is a right triangle. Okay. I guess I'm boxing some of them up, highlighting some of them. I don't know what's going on here. All right, so 3 squared plus 4 squared is blank to 5 squared. So 9 plus 16 and 25. 9 and 16 is 25. So this one's also equal. So this is also a right triangle. Okay? All right, so that's how you label what type of triangle it is. So as you can see, different skill sets here, right? Different theorems. Okay, last one we're going to talk about. They're called Pythagorean triples. So what you noticed up here, right, is that some of these ended up equaling, some of the legs, when you square them, end up equaling the hypotenuse, like this. And they're all whole numbers, okay? That's called a right triangle, and these are called Pythagorean triples because they're whole numbers that equal the hypotenuse squared. Okay, that is not always the case. As you can see here, it didn't work here, it didn't work here, okay, but it did work here. So Pythagorean triples are any time that you have sides of a right triangle, okay, that the Pythagorean theorem holds true when they're positive integers. Like up here, you know, we're finding side lengths, sometimes you get decimals, right? So a Pythagorean triple is only when you use Pythagorean theorem and they're all whole numbers and it works out. And ironically, there are not very many of them, okay? It seems like, oh, there'd be a lot, but there really aren't. But here's the cool thing, is that once you find one, kind of like we did up here, so 3, 4, and 5 is one. Once you find one, you can multiply a number times all 3, so any number. So let's say I multiplied all 3 sides by 2. Well, then that would also be a Pythagorean triple, Okay, and so what I mean is 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. So not only is a 3, 4, 5 triangle a Pythagorean triple, but so is a 6, 8, 10 triangle. Okay, so what we want to do is just state if these are. Well, the easiest way to do it is just check with the Pythagorean theorem. So does this work? Like, are they equal? Okay, 36 plus 64, does it equal 121? No. No, it doesn't. So this is not a Pythagorean triple. Okay. How about 5, 12, 13? So 5 squared, 12 squared equal to 13 squared. So 25 plus 144, is it equal? 169, sure is. So this is a Pythagorean triple. Okay, a little bit longer notes, but obviously I want to be able to get through all those with you. So those are the 4 different theorems that we're going to talk about today and probably the rest of the week, as well as applying them into word problems. So your homework tonight is going to be to do these 6 problems. Again, if you have any questions, let me know. Otherwise, you guys can go ahead and get started. We'll see you soon. Maybe.